Okie dokie, so problem number 4, very similar to all of our other problems so far. We're just analyzing the motion of this arc. Doesn't really matter what the projectile is doing or what it is. In this case, it's a person. We've been doing a lot of balls and arrows also. But now we have a camper diving off the edge of a swimming pool at an angle of 30 degrees with an initial velocity of 8 meters per second. A lot of 8 meters per second in here. Well, let's change it up. Let's say they're diving at an angle of 20 degrees with an initial velocity of 6 meters per second. The question asks, how long is the diver in the air? How high does the diver go? How far out into the pool does the diver land? Same sort of scenario as before. So I recommend starting off by finding your components. VOY, VOX is 6 cosine 20, 6 sine 20, because, pretty formulaic at this point, using our vector formulas or a little bit of trig. We just have to plug this into a calculator. And remember, if you're using your phone calculator, you have to type the angle first, then the trig value, then multiply by the original vector. But we've got that our initial y velocity is 5.64 meters per second, and our initial x velocity, I lied. Our initial x velocity is 5.64 meters per second. Our initial y is 2.02 meters per second. So now, I really like to use this method where I use the final y velocity at the top of the arc as 0. And then figure out that time and double it. So let's keep going with that. I'm really into it. So time to the peak, Vy equals Voy plus Ayt. So this is 0 equals 2.02 minus 9.8t. Subtract 2.02, negative 9.8t, divide by negative 9.8. Oh my goodness, it's 2.05. This is why I can't be trusted. 2.05 divided by 9.8. Ba-ba! 0.209 seconds to the peak. Double that, the time to for the arc is 0.418 seconds. So that's the total time the diver's in the air. And check it out. That's one of our answers. That's the answer to A. We can then we can use this answer to answer C, and we can use this answer to answer B. So let's go B, max height. This is dy after 0.209 seconds. So dy equals Voyt plus 1/2 Ayt squared. Okay. Just gonna plug that in. 2.05, 0.209 minus, because this is going to be 1/2 of negative 9.8, it's minus 4.9 times 0.209 squared. Awesome. Plug that into a calculator. So 2.05 times 0.209 minus 4.9 times 0.209 squared. Fabulous. So his total, their total y distance is 0.214 meters, which makes sense. They're not going to be traveling terribly high above the water if they're just diving off the side of the pool. Next, we find the total horizontal distance. So total dx, so that's after the total arc time of 0.418 seconds. So dx equals Voxt plus 1/2 Axt squared. That's 0. Woo! And then, of course, we've got our Vox here, our initial x velocity. Oh my goodness. There we go. 5.64 times 0.418. And that is how far the diver has traveled out into the pool. Now, of course, I did these super speedy, so if you have any questions, please email me. Oh, I guess it rounds to that. Email me, ask the Homework Cafe teachers, etc. But I believe in you. You got this.